Day 745 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1345, jump game 4. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an array of integers r, you are initially positioned at the first index of the array. In one step, you can jump from index I to index I plus 1, where I plus 1 is less than r dot length, or I minus 1, where I minus 1 is greater than or equal to 0, or j, where r of I is equal to r of j and I does not equal j. Return the minimum number of steps to reach the last index of the array. Notice that you cannot jump outside of the array at any time. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input r equals an array of integers 1, negative 23, negative 23, 404, 100, 100, negative 23, negative 23, 404, 100, 23, 23, 23, 3, and 404. The explanation, or the output, is 3, meaning it took 3 jumps or 3 steps to reach the last index. And the steps are listed right here in the explanation. It says you need 3 jumps to go from index 0 to index 4. So we're going to go from here, this index, to here, because it says we could go where r of I is equal to r of j and I does not equal j. So I is 0 here and I is 4 here. So I does not equal j. Boom. And then r of I is 100 and r of j is 100, which is equal to each other. So we can make this jump. Boom. Then once we make this jump, we're going to go back 1 step, right? We're going to perform this move and go back 1 step from here to here. Now, once we're here at index 3, we could jump all the way to the end right here because this 404 is equal to this 404 at the end. So we can make that last jump. And in total, we were able to do that in 3 jumps. We went from here. That's the first jump. Then we went here. That's the second jump. And then we went here. That's the third jump. Boom. So just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input r equals 7. The output is 0. The explanation says start index is the last index. You do not need to jump. So since we're already at the last index and the goal is to get the number of steps to reach the last index, we don't need any steps because we're already there. Boom. So let's take a look at example 3. So in example 3, our input r equals an array of integers 7, 6, 9, 6, 9, 6, 9, 7. The output is 1. Explanation says you can jump directly from 0 to index 7, which is the last index of the array. So right here, r of I is equal to this, r of j. So we could just make this whole jump, boom, here from here to here, by following this rule right here. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we need to store the size of the array. So we're going to say let n equal r.count. Boom. Then we need a dictionary that maps a value to all indices where that value appears. So we'll declare a variable called m, and we'll set that equal to, it's going to be a dictionary, integer, key is going to be an integer, the value is going to be an integer, and we'll initialize it with 2 parentheses like that. Now we're going to create a visited array to avoid revisiting indices. So we'll declare a variable called viz, and we'll set that equal to an array, open up the parentheses, it'll be repeating, colon 0, comma, count, colon n. Boom. Then we're going to build a dictionary of value to indices. So we'll come underneath this and we'll say for I and 0 dot dot less than n. We'll open up the brackets and we'll say m square bracket r square bracket I. We're going to come outside of that, say comma, default colon square bracket, come outside of that, and we're going to say dot append, open up the parentheses, and pass in I. Boom. Then we're going to create a queue which will be used for the breadth first search. So we'll come underneath this, sorry y'all, we'll come underneath this, declare a variable called queue, and set that equal to an array of integers. Boom, and come outside of that and put the parentheses like this. Then we're going to start our breadth first search from 0. So we're going to say queue.append, open up the parentheses, and pass in 0. Now we're going to mark index 0 as visited by coming underneath this. We're going to declare, we're going to say viz square bracket 0. We're going to set that equal to 1. Then we're going to use a flag to indicate when we reach the last index. So we'll come underneath this, declare a variable called f, and set that equal to false. Boom. Now we're going to counter for the number of jumps. We need to counter for the number of jumps made, so we can come underneath this, declare a variable called c, and set that equal to 0. Boom. Then we're going to continue our breadth first search until the queue becomes empty. So we're going to say while exclamation point queue dot is empty. We're going to open up the brackets and the number of nodes in the current BFS level. We're going to say let as z equal q dot count. Boom. Then we're going to come underneath that and we're going to process all indices at the current jump distance by saying for underscore n0 dot dot less than r, or excuse me, dot dot less than as z. We're going to open up the brackets and we're going to remove the next index to process by saying let I equal q dot remove first, put the parentheses, boom. Then if we reach the last index, we are done. So we'll say if I equals n minus 1, we're going to open up the brackets. We're going to say f equals true, come underneath that, and we're going to break. Boom. Then we're going to try moving one step to the right. So we'll come underneath this, and we're going to say if I plus 1 is less than n, and two and signs, viz square bracket I plus 1 equals 0, then we're going to open up the brackets and we'll say q dot append, open up the parentheses, I plus 1. Boom. Then we'll come underneath this and we'll say viz square bracket I plus 1. We're going to set that equal to 1. Boom. Now we're going to try moving one step to the left by coming underneath this, and we're going to say if I minus 1 is greater than or equal to 0, and two and signs, viz square bracket I minus 1, come outside of that, equals 0, then we're going to open up the brackets, and we are going to say q dot append, append, open up the parentheses, I minus 1. Then we're going to come underneath that and we're going to say viz square bracket I minus 1. We're going to set that equal to 1. Boom. Then we're going to remove, or actually now we need to jump to all other indices that contain the same value as nums of I. Sorry, y'all. So we're going to come underneath this. We're going to say if let indexes equals m square bracket r square bracket I, come outside both of those square brackets, and we're going to say comma exclamation point indexes dot is empty. Then we're going to open up the bracket and we're going to say for x and indexes. We're going to open up the brackets and we're going to visit only unvisited indices. So we're going to say if viz square bracket x equals 0, then we're going to open up the brackets and we'll say q dot append, open up the parentheses, square bracket x. Then we're going to come underneath that and we'll say viz square bracket x, set that equal to 1. Now we're going to remove the following from the dictionary after processing to avoid repeated work and improve performance by coming down here and we're going to say m square bracket r square bracket I. We're going to set that equal to nil. Boom. And if the last index was found, we're going to stop the BFS by coming right here, and we're going to say if f opens up the brackets, we're going to break. Then we'll come right here and we'll say else, we'll open up the brackets. Otherwise, we're going to increment the jump count after finishing the current BFS level by saying C plus equals 1. Boom. Then we need to return the minimum number of jumps needed to reach the last index by coming down here. And we could just say return C, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs properly. Let's see what's going on here. One moment, y'all. Oh, sorry, y'all. This right here should be an array of integers. So the key should be an integer. The value should be an array of integers. So now let's give it another run. See if that did the trick. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 880 milliseconds beats -% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom, or this is the middle, excuse me. This is the bottom of the middle. And this is the bottom of the code, y'all. And yeah, with that being said, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.